Okay, number one, we're going to be writing the equation of a sine graph based on what this tells us in the problem to find A, B, C, and D to write the equation of a sine graph. So, in order to write the equation of a sine graph, I need to identify one full cycle of sine. So, I'm going to use this point here, go through a max and a min, connect to another midline point, and that is my one full cycle of sine. So first let's identify the midline. The midline goes through 2. So the midline tells us how we can identify the amplitude. So the amplitude is that positive distance between the midline and the max or the min. So our amplitude is going to be 2. Next, let's identify our period. Our period is how long it takes to go one full cycle. So our period starts at this point here, and this point is going to be 2 pi over 6. If you notice, our graph is counting by pi over 6. So that means we're counting by 1/6. So that means each point or each line is going to be 1/6. So if we're starting at 2/6, we end over there. Let's figure out where that ending point is so we can figure out the distance in between. So if we start at 2/6, our next point will be 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6. So this end point is 10 pi over 6. So if I take 10 pi over 6 and subtract 2 pi over 6, that will give us our distance in between. So 10 minus 2, we have 8 pi over 6, which simplifies to 4 pi over 3. So that is our period, 4 pi over 3. Next, let's do the phase shift. Our phase shift is how much our graph has shifted horizontally. So our graph has shifted from the y-axis right 2 spaces. And since we're counting, again, by 6, we go from 0 to 1 pi over 6 to 2 pi over 6. So 2 pi over 6 is our phase shift, which can be simplified to pi over 3. So our graph has gone to the right pi over 3 units. So now let's do our vertical shift. Our vertical shift is where our midline has moved to. Our midline has shifted from 0 to positive 2. So our vertical shift is positive 2. So now we have all of our characteristics, and we're going to use them to identify C and B so we can plug them into our general equation for sine, which is A sine of bx minus C plus D. Okay, so let's start by taking our period that we found, 4 pi over 3, and setting it equal to the equation for the period, which is 2 pi over b. So we'll start by multiplying both sides by b. So we have b times 4 pi over 3, which is equal to 2 pi. In order to cancel out 4 pi over 3, we'll multiply by the reciprocal, 3 over 4 pi. So, in simplifying, our pi's cancel. We multiply straight across. 3 times 2 is 6 over 4, which simplifies to 3 over 2. So that is our value for b. Now we're going to use our value for b to find our value for c. So we're using our formula for the period, which is c over b. So c over 3 over 2 is equal to the phase shift that we found, pi over 3. So we're going to multiply both sides by 3 over 2 to simplify to be 3 pi over 6, and 3 pi over 6 simplifies to pi over 2. So pi over 2 is our C value. So now we have A, we have B, we have C, and we have D, and we're able to fill in our general formula. So we have y is equal to 2 sine of 3/2 x minus pi over 2 plus 2. Remember that in our equation, our sine is always opposite of what our phase shift is. So we have a minus pi over 2 when our phase shift has gone to the right pi over 3. And that is our equation, so we are done.